let's talk about the first one together. Okay. All right, so researchers at Manchester Metropolitan University in England determined that if a piece of toast is dropped from 2.5-foot high table, the probability that it lands butter side down is 0.81. Explain what this probability means. All right, I got like too many people talking. Hold on, pause. Nova, go.
Repeated trials, the likelihood that the toast will land butter side down, it approaches 81%.
Okay. Cool. I agree with that. All right. Cool. All right. B, suppose that researchers dropped 4 pieces of toast and all of them landed butter side down. Does that make it more likely that the next piece of toast will land butter side up? Why? Okay. So if you didn't understand that, here are your 2 answers. Yes?
Yeah.
All right. Looking at the next problem, we were talking about cars, minivans, crossovers, SUVs, and pickup trucks, right? On the next problem, it says, what is the probability that the vehicle is a crossover? How do you know? Find the probability that the vehicle is not an SUV or a minivan. And given that the vehicle is not a passenger car, what is the probability that it is a pickup truck? So on the first one, what is the probability that the vehicles is a crossover? How did you get that? Okay. Find the probability, that too. I looked at it, I was like, this is bad, but okay. Find the probability that the vehicle is not an SUV or a minivan. How'd you get that? Okay, so what'd you get? Okay. Good. 0.85. Okay. All right, on the last one, given that the vehicle is not a passenger car, what is the probability that it is a pickup truck? How do we do this one?
It's 0 because isn't it like that's like for image it's not that those overlap. Like you can't have an SUV minivan, you know?
Okay. Given that the vehicle is not a passenger car, right? Here.
Yeah.
Okay. Okay, so not the passenger car, but the rest of them. Okay. So what would be on the top though?
Pickup truck.
Okay, how much is that? Okay. So if you need a visual on this one, the truck is going to be 0.15. On the bottom, it's everything that's not a passenger car added up. Okay, remember given, that's going to have that division, right? Given's going to go on the bottom, and then whatever it's talking about is going to go up on the top. Okay, so you should have gotten 0.278. Bless you. We okay? Right. On the next one, you had Mike's Pizza Shop. You have the following information about 9 pizzas in the oven. 3 of the 9 have thick crust. So Mo, like this is what I'm talking about. Okay. So 2 of the 3 thick crust pizzas have mushrooms. Of the remaining 6 pizzas, 4 have mushrooms. Suppose you randomly select one of the pizzas in the oven. Are the events thick crust pizza and pizza with mushrooms mutually exclusive? Why? Okay. All right. On the next problem, are the events thick crust pizza and pizza with mushrooms independent? Why? Okay. Everybody agree? Jasmine, can you say again? Okay. But we got to prove why, right? So what's the probability of mushrooms?
Probably.
What? Okay. What's the probability of mushrooms given thick crust? Okay, so since those are the same, are they independent? Okay. Okay, so for my visual people,
Why would you do it? It's not the best pizza.
should be either way.
I mean, it should be out of the way, like, while we solve the problem.
Okay, do the probability of thick crust pizza.
Okay. Oh, it's not-
Do the probability of thick crust pizza.
I mean, it's not the same.
Okay,
I know, no.
David.
We can use either one and you can.
So right here, here's a visual. Okay, so you're doing the probability of mushrooms and then the probability of mushrooms given thick crust. And since those are the same, then they are independent. Good. Okay. On that last question, suppose you randomly select 2 of the pizzas in the oven. Find the probability that both have mushrooms. So what's the probability that the first one has mushrooms? 6 out of 9. Okay. On the next one, you're not putting the pizza back. So how many pizzas do you have in the oven?
8.
Out of 8, how many might have mushrooms? Okay, so you're going to do 6 out of 9 times 5 out of 8. And so that should give you 0.417. Questions? Okay. We graded the MCQs yesterday. They were not so hot. Okay. That means that from here on out, we are going to be doing more probability over and over again. Yes, ma'am.
All
right, so looking at these, most sports fans believe in home field advantage. I personally do. The idea that home teams have a slight edge over the away teams because they have a wild fans cheering for them. Let's investigate by looking at the results from 285 games of recent NFL football season. Let X be the number of points scored by the home team, which could be approximately by a normal distribution with mu equaling 22.98, standard deviation 9.3. Y represents the number of points scored by the away team. Normal distribution of mu equals 20.90 and standard deviation of 9.41. So define D equals X minus Y and assume that X and Y are independent. Okay, so calculate and interpret what the mean of D is. So how would we go about doing this one? Okay, but how? I'm sorry, you just said it. Sorry. Okay, so mu of D is 22.98 minus 20.90. Why is it minus? Find the difference between those two. Okay. 2.08. Now, when we interpret, how do we interpret? Many. If you choose many NFL games, the average difference in points for home versus away is 2.08 points. Now, standard deviation, the way to calculate it is to take each one of the standard deviations, plug it in, square it, and then take the square root. So 9.30 squared plus 9.41 squared. And that's going to give us 13.23. We okay? All right, I'm going to read C. So suppose we randomly choose a game and record the number of points from the home team and then independently randomly choose another game and record the points of the away team. What is the probability that the home team has more points? How do we go about solving this one? Yep. Okay, go.
So if there, like, would you ever have to interpret the standard deviation?
Yes.
And like, how would I put that?
How would you interpret the standard deviation? And you just have to put it in context. So you would have to talk about home versus away points. Yeah. The standard deviation is this many from the mean, and you got to state the numbers. Yeah, babe. Yes. Yep. Good. Okay. All right. So on C, how do we go about solving this one?
So I just have to find the Z-score between like 0 and then the mean, like 0 minus the mean and all that divided by the standard deviation.
Okay, so you use part A and B in order to do that. Why are we doing 0?
Because we're trying to find the probability that no place. So I assume that like finding the Z-score might be like, so once we calculate it, it will be greater if I'm very certain.
Okay, because remember, we're finding the difference between those two, right? If it's a positive number, then it would be the home team has more points, right? So that's why we're doing greater than 0, okay? For my visual people, on the normal curve, the mean is 2.08. We're finding it at 0. We're finding this, okay? Remember, normal curve, we have a mean of 2.08. Our standard deviation is 13.23. Okay. When we find the Z-score for this one, it's going to give us negative 0.16. Now what do we do? Okay. So we would go to our Z-score table. We would find the negative side. Okay. We're going to go to 0.16. And that would be 0.4364. 0.4364. Are we done? Why? 4364. So what are we going to do? Okay, so 1 minus 0.4364. Why are we subtracting it from 1?
Because the number that we found, that's for everything less than 0, but we're trying to find when the difference should be greater.
So on a normal distribution, normally it's read from left to right, right? So we do less than. This question is asking greater than. So we have to do 1 minus what we just found. Yeah. So that's going to give me a total of 0.5625. 5625. That's all. Let's take a look. Will the U.S. win the World Cup? The answer is no. Like we already know, right? Okay, the U.S. women's soccer team is good, is doing some calculations to help prepare for the upcoming World Cup. They are convinced that the toughest matches are likely to end in a tie. These matches require a shootout to break the tie, where each team gets 5 penalty kicks. Okay, they believe that they will need to make 4 or more penalty kicks to win. Okay, we ready? So, over the history of the World Cup, about 70% of penalty kicks in a shootout are made. So, this is the probability of success So we're going to say P equals 0.70. Okay. The 5 penalty kicks, these are the number of trials. So N is going to equal 5. Okay. Everybody okay with those two things? Okay. And each trial, either they make it or they don't make it, right? Okay. Let's assume this probability for each of the players on the US team and that each kick is independent. Okay. So each trial is independent. So what is the probability that the team will make all 5 penalty kicks? So on the first kick, what's the probability of them making it? Okay. On the second one, what's the probability of them making it? What about the third one? Fourth one? Fifth one? Okay. So that's 0.7 to the 5th power, right? Somebody type that into their calculator and tell me what you get. 0.168, right? Okay. And number 2, it says, what's the probability that the team will make exactly 4 of the penalty kicks? So one way this could happen is making the first 4 kicks and then missing the last one. That would suck, right? That would be terrible. So 0.7, I'm gonna raise it up in just a second. 0.7 times 0.7 times 0.7 times 0.7 times 0.3. Okay. So 0.7 times 0.7 times 0.7 times 0.3. Can somebody type that into their calculator and tell me what you got? Remember, that's 0.7 to the 4th power times 0.3. Okay, so that's going to give us 0.072, right? Name another way to make exactly 4 penalty kicks. What's another way this could have happened? You can miss the 3rd or you can miss the 4th. Okay, so we could say make, miss, make. And that would look like 0.7 times 0.7 times 0.7 times 0.3 times 0.7. So that would be 0.7 to the 4th power times 0.3. Again, would still give us 0.072. So what do you notice about probabilities in part A and part B? Okay, they are the same. How many different ways are there of making exactly 4 of the penalty kicks? Yeah, for sure. Let's write all of them out. Okay, so that first one, we can use checks and X's to represent these, so we don't have to write out all the words. We can make all the first 4 and then miss the last one. We can make the first 3, miss the 4th one, make the last one. We could make the first 2, miss the 3rd one, make the last 2. And we could miss the first one. I'm sorry, miss the second one, make the rest. And then we can miss the first one and make the last 4. Bless. Yes. Hey, friend. Yes. Yeah? Oh, you should probably get back in there. You, that was on the test though.
No. Well, I need to do better on that, so I can replace that.
Okay, we'll go get it knocked out. You got it, Tobes.
Yeah. Well,
See ya. All right, so just like what Mo said, there are 5 ways to do this. Okay. So we're going to represent this by saying 5, choose 4. And that's equaling 5. Okay. You're going to see this written out as the number of trials, C, whatever you're trying to like get. Okay. Mm-hmm. All right, so overall, what's the probability that the team will score on exactly 4 of the penalty kicks? So what's the probability that they will score exactly 4 of the penalty kicks? What is that in decimal form? 1/4. So what's the likelihood on the first one? 0.072, right? No, we're gonna add, right? What's the likelihood on the second one? What's the likelihood on the third one? What's the likelihood on the fourth one? What's the likelihood on the fifth one? So what do we get? 0.36. All right, I'm gonna. Okay. One student calculated the probability of making exactly 4 of the penalty kicks using this formula. Identify what each part of the formula represents. Okay. So we're gonna come down here. They said the probability of exactly 4 successes out of 5 trials. So this 5 is the number of ways. 0.7 represents the probability of making it. 0.3 is the probability of missing. 4 is the number of makes that we want. And 1 is the number of misses. You don't have to type it into your calculator. Like if you type in 0.3, it's raised to the first power. Yeah. But it's not always going to be 1 miss. It can be 2 misses, right? Okay. So here's the notation for this guy. We've got the probability of making 4 exactly is equal to 5 C4, probability of 0.7 raised to the 4th power times 0.3 raised to the 1st. Yeah. Our event of the penalty kicks. We're making exactly 4. Up at the top.
What is this meaning again?
Choose 4. So we're talking about the combinations. And you can actually do this in your calculator. Fun fact. I'll show you that in just a second. Okay. So if a World Cup game ends in a shootout, what's the probability that the US team wins? Four or more, right? You got to get 4 or more. So what's the probability of getting 4 or more? What's the probability of it getting exactly 4? Okay, 0.36, right? What's the probability of getting all 5? 0.168. So 0.36 plus 0.168, what does that give us? 0.528. All right, once you're finished, go ahead and flip that page. Okay, so this is called binomial random variables. So the first thing that we learned about on this is called a binomial random variable. X represents the number of successes of whatever you're talking about. Okay, so binomial random variable. Binomial random variable. Okay, X represents the number of successes. Okay, it is binary because it's either success or failure. You have independent trials. One does not impact the next, right? The number of trials is fixed. So out of the 5 kicks that we did, and I'm gonna write this one over here. The same probability of success. So each time that we made a kick, we had the probability of making it 0.7. We talked about the binomial formula. Okay. So probability of X equals whatever number that you're trying to look at is equal to N C K, probability of K times 1 minus P raised to the N minus K. So this looks a little crazy, but when you put the numbers in it, it doesn't look so wacko. Just a reminder, this is the number of ways to get K successes. This one. This is the probability. N is. 1 minus P is the probability of failure. This is the number of failures. This is the number of successes. And I'm going to pause and give you. Okay, really quick, I want you to pay attention to the letters of these. So we got B-I-N-S, bins. Okay. So on part A, for number 1 for your check your understanding, you are going to define whether or not this is a binomial. Plot twist is it's a binomial. Okay. But the way that you have to describe it is you have to say, hey, it's binary. This is why. Hey, it's an independent trial. This is why. Hey, here's the number of trials that are fixed. Here's the probability. Okay. So on number 1A, you're going to define why it's binomial. Okay. Again, it is binomial. Tell me why. Okay. So I'm going to give you a couple minutes to try those problems. Okay. So from this game, in the past, you know that you have an 80% probability of whacking the mole before it drops back into a hole. The moles pop up randomly, and your ability to whack any particular mole is not affected by whether or not you whacked the previous mole. There are 20 moles to be whacked during one round of the game. Let X represent the number of moles you are able to whack in one round. Okay, so why is this a binomial distribution? Is it binomial? Yes.
So each
either does or doesn't get whacked, so that's the for being binary. The second, like one of the so you putting the mold the first time that raise our leadership pay out. There's 20 moles that's your in fixed number of trials, and then the probability of success will change.
Okay, so if you said it was binary, you either whack or not. Okay. Obviously, you use probably a better sentence structure, but it's independent, so it's not affected by the previous one. The number of trials is fixed. We're at 20, and the same probability of success for each trial. That's 0.80. Okay. Next, you play skee ball. Dude, I could have souls on skee ball. You know that you have 10% probability of getting any given ball in a 100-point hole. Let y equal the number of balls you must roll to get into the 100-point hole. Is it binomial? Why? No, because the number of trials is not fixed. It doesn't say, hey, you get 20 chances to roll it into the 100-point hole, right?
People machine have a certain number of calls. That's like that number that you're using.
Yeah.
Now, you told me that, you have to roll, like the last sentence, let by the number of balls you must roll to one in the point hole. So we can assume that they're trying to do it until they actually.
So they just keep rolling. Okay. All right. So now you play a game called Tsunami Duck Pond. That sounds fun. Where there are 100 ducks and they get pummeled by tidal waves. Oh, among the 100 ducks, there are 20 with stars on the bottom and 30 with circles, 50 with squares. You must reach your hand into the tsunami and randomly select a duck. If there's a star on the bottom of the duck, you win. After you select each duck, you must place the duck back into the tumultuous water. Yeah, that's a good word. Let W represent the number of times you win if you play this game 10 times. W is a binomial random variable. Identify the fixed number of trials and the probability of success from each trial. Okay, so how many trials do we got? 10. Okay, so N is going to represent N. What is our probability of getting a duck with a star on the bottom? Out of how many ducks do we have? Okay, so out of 100, we're getting 20, right? So that's going to be 0.2. Okay. Find the probability that you win exactly 3 times. Okay. So we want the probability of winning exactly 3 times. We're going to use our formula. How many trials do we have? Oh, try again. 10. Choose how many exactly 3 times, right? Okay. Times 0.20 raised to the third. And our number of losses, or our probability of losses, is 0.8. We're going to raise that to the 7th power because 10 minus 3 gives us 7. So what are our chances of winning? What are our chances of winning? Exactly 3 times. Okay. If you go into your calculator, okay, so you're going to need your calculator for this. I can't do this. I think you can actually do this on Desmos. It does allow you to do this on Desmos. But if you go into your calculator and you hit add calculator, okay, and then you hit menu, and go down to what number 5 where it says probability. you're gonna go down to combination. And then it gives you this, NCR, and it says parentheses. Inside those parentheses, you are going to say 10, comma 3. So the number of trials, comma, the number of successes. When you do that, you should get 120, right? Okay, so that's what this represents. Okay, now you're going to take that 120 and you're going to multiply it by 0.20 raised to the third times 0.80 raised to the seventh. Let's see if we can type that all in at the same time. Yeah, a combination. So our 10 is the number of trials. 3 is the number of successes. So out of the 10 trials, we got 3 successes. So you're going to hit menu. You're going to hit 5, go down to combination, and then you're going to hit 10, comma 3. Got it? Okay. Now you can type this entire thing in at one time, like this entire equation in, and you should have gotten, I think it's 0.2013. 0.2013. I was freshman year of college. See? That's great. Good times. We okay? No? Yes? Need more practice with this, maybe. Yes. Okay. Not does much. Nope. Okay. Pop quiz. Not everybody perk up. All right, so it's time for a pop quiz. We hope you're ready. The quiz consists of 5 multiple choice questions. Each question has 4 answer choices labeled A through D. Now for the bad news. You don't get to see the questions. Make your best guesses. So on your paper, you have 5 multiple choice questions. Go ahead and on your paper, write 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I want you to guess what the answer is. A through D. Okay, everybody's got to do it though, because otherwise it messes everything up. Okay, so 1, 2, 3, 4, 5 on your paper. Okay. All right, you got 2 seconds. Go. So you should be writing on your paper. You label 1, 2, 3, 4, 5. You're taking a quiz that you cannot see the questions. A through D. Make your selection now. This is how I feel y'all took the last test. Blindly.
That's how I couldn't believe it.
Oh. Yeah. All right. Everybody finished? You finished your quiz? Okay, here are your answers. Mark your questions. All right, the first answer, so number 1 is A. Number 2 is C. Number 3 is B.
Let's go.
Number 4 is D. Number 5 is A. Okay. So go ahead. Right at the top of your thing, number correct. You did not get all 5 right. Oh, liar. Oh my God. You set it on a throne of lies. I cannot wait for Christmas. It's fine. All right. So let X represent the number of correct guesses. Is this a binomial setting? Okay, so remember, we have to use bins in order to really kind of define that. we get right or wrong, right? A success would be getting it correct. A failure would be wrong. Okay. Are they independent? Okay. What about number of trials? What was our number of trials? Okay. And was it the same probability every time? What was the probability? Okay. How many of y'all got like a 3 out of the 5 correct? 4 out of the 5 correct? 5 out of the 5 correct? Just you. Just you. Okay. Just you. What about 0? What if you got none of them correct? Yes. Okay, good. Okay. So we're going to calculate the probability of getting exactly 2 correct. Okay, so the probability of exactly 2 correct. I want you to take a moment, see if you can write out the equation for that guy. Okay? Take a second.
Formula on the top.
I think it is on the formula sheet. I'm gonna check before I tell you that though.
I feel the probability in total. Let's say correct.
Okay, the answer to that is no. Your calculator does it for you though. Yep. All right. Okay, so we've got 5, choose 2. Okay, what's our probability of success? 0.25. How many successes do we want? 2. What's our probability of failure? 0.75. And how many is that going to happen? 3. Okay, when you put that in, you should get 0.264. There is another way to do this in your calculator. I think so, but I gotta remember how to do it. No. Easier. JK. Okay. So I'm going to show you this in a little bit, but I'm going to go ahead and get you to write it down. I've got to make sure that I put this on the how-to calculator. So you're going to do binomial PDF, and you're going to have n equals 5, p equals 0.25, and x equals 2, and you're going to get the same thing. Okay, I'm going to show you this in just a little while. It should be under the menu. I'm having to unlearn TI-84 and then learn TI-Nspire. So. So it's under distributions. There it is. Okay, so if you go to menu and you go to probability and you go down to distributions and you scroll all the way down to binomial PDF. And then you're going to type in the number of trials, which in this one was 5. The number of successes is 2. Should be 2. So how many times that's going to happen? Okay, so you're typing in this stuff and it does it for you. You got an error? Yeah, we love a good error. The x value should be 2. Yeah, I got it. Everybody got it? Yes? Okay. Yeah. So that's exactly what we got here. Okay. All right, so we're gonna go ahead and complete the table. Go ahead and take a moment. Go ahead and complete the table. What's the probability of getting 0 correct? What's the probability of getting 1 correct? 2 correct? 3 correct? Bring it to- Okay, go ahead and take a moment, fill in that table. Why'd you do it like 7 times? Okay, let me.
Bro.
How did your test work? We've got to connect you to another CX. So go grab the alternate CX. Find out who has this one and that's not already in test mode and bring them both to me. I have to figure out about that. But you're to like do this. So